how LNG fits within the energy transition. A lot of the previous section has been building up to this. This is one of those items in the energy trilemma, as it's called, that governments have to deal with. This is the emissions one. So how does LNG fit in? Well, if you look at a cubic meter or whatever of natural gas and what happens to it as it's used, and when that cubic meter of natural gas is burnt, it turns into a variety of products. The main one is carbon dioxide and water, obviously. But along the way, there's also the issue of, is any of it leaking? And when it leaks, the main component of that is methane, which is a very potent greenhouse gas. And cubic meter for cubic meter, I think it's something like 60 to 80 times more potent than carbon dioxide. But on the other hand, not that much of it is leaking. That's the view of some people. Others think more of it's leaking. That's one of the difficult issues for LNG. But if you just look at that cubic meter, when you burn it, 75% is of the emissions come from the combustion of that gas in a power plant, assuming that's where it goes. And if it's LNG, 25% are in the processing part of the chain. So starting from the bottom, you lose about 1% in that regasification process I mentioned earlier, about 16% of shipping. So this is 16% of 25%. 33% is in liquefaction, which if you multiply those together, you lose about 8% of the volume in liquefaction. And then the more difficult area is, what are the emissions from the upstream production, and this can vary depending on how that production is generated. If you remember the map I showed of Australia, with the northwest was traditional production with just a few wells. Then the eastern production was thousands of wells producing gas from coal seams. Those are the two extremes of how big that red bar is. If you're just producing from a few wells, it's quite controllable, and your emissions, especially methane emissions, from that will be quite small. However, if you're developing thousands of wells from producing gas from coal seams, the potential for methane leakage in that is much, much larger. And one of the challenges the industry, and not just the industry, everyone has, is how big are those emissions? And there are estimates and ways of trying to work out how big they are. But the emissions of methane, you can't smell them, you can't see them. And one of there are a range of initiatives to try and better understand how big are methane emissions in that part of the chain, this part up here, the upstream. And that ranges from satellite data to drones and a whole range of other things. That's one of the areas of uncertainty and real academic argument around how big are those upstream emissions. But if we just talk about how does LNG play a part in decarbonisation, the US is a very, very good example of that. And this is US primary energy consumption since 1950. This goes way back. So this is everything, including transportation and things like that. And you can see that the US was really driven on coal. This is coal explaining this black line. Natural gas was also going up as well, but it's very, very stark at this point when that shale gas revolution happened in sort of around about 2005, 6, 7, 8, and cheaper natural gas in very abundant quantities came in to the energy system and just started displacing coal. So you can see the brown line, natural gas has just continued to go up and coal has dropped off a cliff. And this, for all the development of renewables, which have happened down here, the green line, the way the US has reduced its carbon emissions over the last 15 years has been primarily with the replacement of coal by natural gas for power generation. That's what's made the big difference. And this little inset graph here highlights it again. That's total US CO2 emissions. So you can see it growing here up to 2005, 6, 7, and then it drops down. So that's consistent with coal being replaced by natural gas. So that's the opportunity, the large-scale displacement of coal. Now, one of the sort of political debates around this is that, well, that's not a perfect solution, is it? We'd much rather replace coal with renewables. In an ideal world, that would be good. But when you look at the practicalities of doing that, it's really not there. So the question is, should you do something that significantly reduces emissions by replacing coal with gas? Or should you try and get a perfect solution and replace everything with renewables? But the problem is you'll then find it doesn't happen, and you miss your targets and all those sorts of things. So our view is that this sort of scenario where you replace coal with natural gas is going to be a very, very significant part of the energy transition story, because it maintains reliability of the power system, it backs up renewables that can be intermittent, and gives you a way to reduce your emissions without undermining your energy security. But the critical piece that made this happen is that the natural gas was cheap and it was available. And if you don't have that, making this scenario work becomes very, very difficult. So this is the critical thing for the countries like the Philippines, is that where you have very significant coal-fired power generation, if you are going to replace it with natural gas, you've got to make sure it's available, affordable, and reliable. Otherwise, that's not, may not be a good way to go. So that's the challenge for the natural gas industry, is making sure it's affordable and reliable. And that's why, if I go back to the US export pause, why, even though it hasn't affected LNG availability in the very near term, or even the medium term actually, what it has done is undermined confidence that in the long term it's going to be available. And if you're going to go with a strategy like this, you need to be confident that in the longer term the gas is going to be available. There are a lot of things that need to be done to decarbonize. And there are a whole range of different technologies that need to be developed. Things like ammonia, carbon capture and storage. I'll talk about in a second. But what LNG and natural gas do is they provide firm capacity available at short notice to complement into renewables. So they're really a very good partner for renewables. And I mentioned it just has to be available and affordable. This is life cycle CO2 emissions, and there are some debates over this sort of chart. Some people have different versions of it. But in general, if you're generating with coal, this is how much CO2 you put in the atmosphere per kilowatt hour. And generally, natural gas will be about half, roughly, depending on what those upstream emissions that I mentioned earlier were. But generally, it's around about half. So that's what makes it possible to reduce your emissions. You replace coal with natural gas. As you go along the stages of the supply chain, where do you get most of the emissions? I mentioned liquefaction is quite high. It's still quite small, really, about 8%. Most of the emissions come from the power generation, which is that bar on the second from the right. And this is the emission intensity of gas, LNG, and coal into Europe. So this is US LNG going into Europe. On the far right is coal in Europe. Again, it's around about twice what you get from burning gas. I'm focused a lot on methane here because I think it's an area that's becoming very, very, very much more of a focus. You can reduce methane emissions in a number of ways. Things like reducing flaring, but it's kind of unglamorous work on things like making sure seals work. But it's straightforward technology, and it's things that can be done now. But it's not high profile, but it's the sort of thing that can have very significant impact on climate change. And as I said, it's one of the most cost-effective strategies for reducing emissions. You can see that that's the global methane level has been continuing to increase, as it has with CO2, obviously. It's these sorts of things that you can do to reduce methane emissions. And none of it is, as I said, very glamorous. It's very important. And it's something that the industry is committed to do, increasingly so as well. I think one of the questions that recently a satellite has been launched a few months ago that is going to do global analysis of methane emissions. Because one of the issues with methane emissions is that the companies or countries that report them may not be the countries that are actually making most of the methane emissions. So one of the things this satellite will do is give global view of emissions. And so some of the countries that maybe are not so good about reporting, maybe Russia, some of the countries in North Africa and the Middle East and so on, you'll have a sort of level playing field. Is that working yet? There we go. Thank you. I'll just mention carbon capture and storage, which is something, this is quite interesting. You may have, I'm sure you've heard of this. This is where you have carbon dioxide, you re-inject it into the ground, into some sort of geologic formation and store it there. And we did this on a very large LNG project in Australia called Gorgon that I was lucky enough to work on. It is definitely going to be part of the energy transition story. It's not without its challenges, but you basically take carbon dioxide, and it's better if you've got a stream of carbon dioxide that's like 100% carbon dioxide, a very high percentage. And you send it out by pipeline to wherever and re-inject it, usually into something like a depleted oil field, or you can just put it into a saltwater aquifer, that sort of thing, into sandstone, basically porous rock. And because of when you compress it, if you put it into the right sort of formation, it will just stay there. And one of the opportunities that's emerging is to turn this into a business. And you could potentially transport CO2 in tankers from countries like Japan or Korea, where there aren't necessarily the geological opportunities to store CO2 like this, to countries where they are. And a number of those countries will be in this region, where they could be in Indonesia, Malaysia, and so on. And to be paid for doing that and storing that carbon dioxide. There are a lot of regulatory issues around doing that, around who gets the emissions credits and all sorts of things. One of the pieces of work actually that Andrew is doing is to try and put a framework around that within the region to allow us to do that cross-border transportation. So we've been doing that for the last year or so. But this is it's an area of technology that gets it's the concept of injecting carbon dioxide has been around for a very long time, almost 50, 60, 70 years. It was originally done to improve the recovery of liquid hydrocarbons. So it's not a step out in terms of technology. I think the challenge is going to be around cost. Is it too expensive to do? And as with anything, the more of it you do, the cheaper it gets. And so I think it's going to be an important part of the solution. In terms of where is it being done at the moment, there are a lot of projects in the US. A lot of these are around improving recovery of oil. There are a number in China. This is the very large one in Australia that we worked on in Global, some in the Middle East. But there is an opportunity, I think, for Southeast Asia to develop this business of sequestration of CO2 for other people. And finally, I won't dwell on this, but one of the difficulties around anything to do with greenhouse gas emissions is the number of different standards and protocols and so on there are around estimating what they are and who's responsible for them. There have been various initiatives to try and standardize and improve and those sorts of things, and those just need to be worked through until you can come up with consistent frameworks across the industry to allow for greenhouse gas emissions to be accounted for. But that final bullet point is that the cross-border carbon accreditation framework that I mentioned Angier is working on to allow tankers of CO2 to move across borders and store CO2. I think that's lunchtime. We've maybe got, if there are any questions on that one, I'm happy to take them. Otherwise, we'll lunch.
All right. Thank you very much, Mr. Theobald, for another thorough presentation on LNG and the energy transition. Let's give him a round of applause.